Hello students, welcome to the next lecture of Strength of Materials. We are currently studying unit number 1, Simple Stresses and Strains, and in the last lecture we have started with the sums on composite members in series. So let's move forward in this lecture. So firstly we are going to study a new term which is known as modular ratio. So what it is the ratio of modulus of elasticity of two different materials or same materials. So it is denoted by small m. So m is equal to E1 upon E2. So you have studied the term Young's modulus or modulus of elasticity, which is known by capital E. So its unit is Newton per m square. So the ratio of Young's modulus of two different materials, suppose aluminum steel, aluminum timber, steel timber, the ratio of both of these is known as modular ratio, which is small m, and modular ratio does not have any specific unit. So the next important part of this topic is the stresses in bars of composite sections. We have already studied the sums on stresses in bar of composite section in the last lecture about members in series, and now we are starting with the next type, which is members in parallel. So let's study some important formulas, important points before going to the sums. The first point is deformation are same in each material, means delta L1 is equal to delta L2. So as composite sections means a section consisting of more than one or two members. So whatever the change in dimensions of deformation will be there, the deformation between both the members we consider as same, means delta L1 is equal to delta L2. If the length are same, the strain in each materials are same. So as both the materials, if they are having same length, then the strain in each of the materials will be also same. So therefore E1 is equal to E2, means strain in material 1 is equal to strain in material 2. As you know, formula for small e is sigma 1 upon E1 is equal to sigma 2 upon E2. So this formula is actually for Young's modulus, which we had studied as capital E is equal to sigma upon small e. Here for our convenience we have changed the formula in terms of E, means small e. So it becomes sigma 1 upon E1 is equal to sigma 2 upon E2. So this is the important formula you need to remember for solving these types of sums. Lastly, third step is to find total load, which is P is equal to P1 plus P2. So majorly we have three steps, but for calculations we require only two steps, that is sigma 1 upon E1 is equal to sigma 2 upon E2, and total load P is equal to P1 plus P2. So question number 1, a RCC column or a reinforced concrete column of circular section of 50,000 mm square cross section area carries 6 reinforcing bars whose total area is 600 mm square. Find the safe load the column can carry if the concrete is not to be stressed more than 3.5 megapascal. Take modular ratio or modulus ratio M for steel and concrete as 18. So we'll draw a reference figure, as it is a RCC column is a circular one, so we draw a circle, number of bars are 6, so we draw 6 bars. So write the given data, area of column is given as 50,000 mm square, number of reinforcing bars are 6, so it is written as number of reinforcing bars equal to 6. Total area of steel bars is given, means AS is given as 600 mm square. Maximum stress in concrete sigma C is given, which is 3.5 megapascal. As you know, the conversion megapascal means Newton per mm square, and modular ratio M, which is ES upon EC equal to 18. Now here why is it written as ES upon EC? As this material, so here why it is written as ES upon EC? Because RCC column is composed of steel and concrete. So the ratio of two materials Young's modulus is ES upon EC, which is given as 18. Area of concrete we have to find out. Now this is an important step you should understand. There are three types of area. Firstly, area of this whole column. Secondly, area of the steel bars, and third, area of the concrete between the steel bars. So the area of column is the sum of area of steel plus area of concrete. So here area of column is given, area of steel is given. So how can we find the area of concrete? Is area of column 50,000 mm square minus area of steel, means minus 600. So area of concrete is 49400 mm square. So the stress in steel we have to calculate, which is sigma s is equal to es upon ec into sigma c. Now as per the formula, es upon ec value we have 18, sigma c from the question we have 3.5. So substitute, we get 63 Newton per mm square as sigma s. So final step, the shape load the column can carry is given by formula P is equal to P1 plus P2 means sigma s as plus sigma c ac. So sigma s we found 63, area of steel we had 600, here it is wrongly written as 500. Sigma c we have 3.5 and AC we have 49400 mm square. So the final step, that is shape load P the column can carry is P is equal to sigma s as plus sigma c AC. So sigma s we have 63 Newton per m square, as we have 600 plus sigma c we have 3.5 and AC we have 49400. Now here the term AC means area of concrete. You should not denote it by area of column. Area of column is always denoted by only A, and area of concrete as AC, area of steel as AS. So here we have to take the value of area of concrete, not the area of column. So finally we get the answer by calculator 210700 Newton. In terms of kilonewton, you have to divide this value by 1000, which is equal to 210.70 kilonewton. So we start with the second sum. A load of 270 kilonewton is acting on a short RCC column of size 200 mm into 200 mm. The column is reinforced with 10 bars of 12 mm diameter. Determine the stresses in steel and concrete if the modulus of elasticity of steel is 16.5 times that of concrete. So draw a reference figure, a square column, total number of bars are 10. So first 4 bars in corner, 2 bars in the middle and remaining 2 bars at the center. So write the given data. Area of column is given as 200 into 200 means 40,000 mm square. Load P as 270 kilonewton means 270 into 10 to 3 Newton. Diameter of steel bars is given as 12 mm. Number of bars are 10 and modular ratio is given as M is equal to ES 16.5 times EC. How this equation came? So read the question once again. If the modulus of elasticity of steel is means ES is means equal to 16.5 times that of concrete. 16.5 times that of concrete. So first we calculate area of steel by formula N into pi by 4 ds square. N mean number of bars, which is 10, pi by 4 ds is 12, right, 12 square. We get 1131 mm square as area of steel. So how to calculate area of concrete? So AC is equal to 40,000 minus 1131, which comes out to be 38869 mm square as area of concrete. So next, for composite member, strain in steel is equal to strain in concrete, as we studied in the formulas. So sigma s upon ES is equal to sigma c upon EC. So take the ES term on the right side. Sigma s is equal to ES into sigma c upon EC. Now we have sigma s is equal to 16.5 times sigma c after rearranging it from the question data. So the total load P is equal to sigma s AS plus sigma c AC. So the value of load is already given in the question, which is 270 into 10 to 3. Here it is written as 103, but this 3 should be in the raised form, means 270 into 10 to 3 equals to 16.5 sigma c, which is this term, as sigma s has value of 16.5 times sigma c, into area of steel we calculated 1131 plus sigma c as it is, and AC value we have means area of concrete 38869. So right hand term on calculator you can calculate keeping sigma c as it is. We get the value 57530.5. Left hand side as it is. Now keep this sigma c on one side and take all the numericals on the right side as the denominator of 270 into 10 to 3, which is 57530.5. So ultimately by calculation we get sigma c is equal to 4.69 Newton per mm square. Now using this value of sigma c, we'll put it here. We get sigma s equal to 77.385 Newton per mm square. So in short, we had to calculate stresses sigma c and sigma s in this numerical. Next sum. A square RCC column is 300 mm into 300 mm in cross section. It is reinforced with 4 bars of 20 mm diameter. Determine the load carrying capacity of the column if the allowable stresses in concrete and steel are 7 megapascal and 140 megapascal respectively. ES is equal to 200 GPa and modular ratio M is 13. So this is a column. There are 4 bars of 20 mm diameter, means 20 mm 5. Dimensions are 300 mm by 300 mm, and this triangular and dotted indicates concrete. So given data, A is equal to 300 into 300, sigma C is equal to 7 megapascal, sigma S is equal to 140 megapascal, ES is equal to 200 GPa, means 200 into 10 to 3 Newton per mm square or MPa, and modular ratio is 13. So we have to find the value of load P. So area of column we find. Area is equal to 300 into 300 means 90,000 mm square. Area of steel as AS is equal to N into pi by 4 D square. N is number of bars are 4. Pi by 4 D means 20. So it is 1256.64 mm square. Area of concrete is AC is equal to area of column minus area of steel. Area of column is 90,000. Area of steel is 1256.64. So you get area of concrete as 88743.36 mm square. So for the composite member, strain in concrete is equal to strain in steel. Means sigma C upon EC is equal to sigma S upon ES. So rearranging this term, we get sigma S is equal to ES upon EC into sigma C. Now this ES upon EC means M, which is 13. So write it as 13 sigma C. So the consider maximum allowable stress in concrete, which is given in question as 7 megapascal. Means sigma C is already given in question as 7 megapascal. So we will replace it in this equation. So sigma S is equal to 13 into sigma C, means 13 into 7, which is 91 megapascal. Now we got 91 megapascal as the answer of sigma S. But in question the sigma S value is limited to 140 megapascal. Means 91 is less than 140 megapascal, means it is suitable. If the value would have been more than 140 megapascal, we would have rejected it and considered sigma S as 140 megapascal for further calculations. So load carrying capacity means load P is equal to PC plus PS, means sigma C AC plus sigma S AS. Sigma C stress in concrete we have 7, right, 7. AC area of concrete we have 88,743.36 plus sigma S we have 91. Now here you have to take this value of sigma S, not this 140 megapascal. This value we calculated and it is safe as it is below 140, so we take this value. So 91 into area of steel, which is 1256.64. So ultimately we get the answer 735.55 into 10 raised to 3 Newton. Either write in this way or remove this 10 raised to 3 Newton value and directly write 735.55 kilonewton. Because load is usually denoted in terms of kilonewton. You can denote the answer in both the terms, both are correct. So last sum of today. A reinforced concrete circular column of 400 mm diameter has 4 steel bars of 20 mm diameter embedded in it. Find the maximum load which the column can carry if the stresses in steel and concrete are not to exceed 120 megapascal and 5 megapascal respectively. Take modulus of elasticity of steel as 18 times that of concrete. So this is circular column. There are 4 bars. So we put the 4 bars in such a way that there are at all the faces. This is the diameter 400 mm. So given data is diameter of column D is 400 mm. Number of reinforcing bars are 4. Diameter of bars is 20 mm. And maximum stress in steel sigma S max is 120 megapascal, means 120 Newton per mm square. Maximum stress in concrete is given as 5 megapascal, means 5 Newton per mm square. And modulus of elasticity of steel is ES is equal to 18 times EC. So this is very important. We know that the total area of the circular column, the formula A is equal to pi by 4 d square. Diameter is 400 means pi by 4 400 square. So it becomes 125 660 mm square. Now the area of steel means area of reinforcement. We calculate AS is equal to N into pi by 4 d square. N means number of bars are 4, so we write 4. 4 into pi by 4 d means here the diameter is 20 mm, so 20 square. So we get area of steel as 1257 mm square. Area of concrete we found by formula area of column, which is 125660 minus area of steel 1257. We get area of concrete as 124403 mm square. So first of all, let us find out the maximum stresses developed in the steel and concrete. We know that if the stress in steel is 120 Newton per mm square, then the stress in concrete is given by, we have the formula sigma C is equal to EC upon ES into sigma S. Now ES value was 18 times EC. So here it is inverse, so we write as 1 upon 18. Means if we convert this in the form of EC, so ES upon 18, so here it is 1 upon 18. So 1 upon 18 into 120, which is given as stress in steel in question 120 megapascal. So 1 upon 18 into 120 gives us sigma C value 6.67 Newton per mm square. So it is more than the stress in concrete, that is 5 Newton per mm square. Means in the question the stress in concrete was limited to 5 megapascal, and here our value came 6.61. So this is not preferable and rejected. Thus these stresses are not accepted. Now if the stress in concrete is 5 Newton per mm square, the stress in steel will be found as sigma C is equal to ES upon EC into sigma C. Now ES upon EC ratio is 18 into sigma C. From the question we have 5, we get sigma S value as 90 Newton per mm square. So this is the correct value. It is less than the stress in steel, that is 120 Newton per mm square. Now we calculate the value of sigma S as 90. The question value is 120. Means what? This value is less than 120, means acceptable. So it is thus obvious that stress in concrete and steel will be taken as 5 Newton per mm square and 90 Newton per mm square. Means this value of sigma S we consider, and from question this value of sigma C we consider. Therefore maximum load which the column can carry is given by P is equal to sigma C AC plus sigma S AS. Sigma C we take 5, AC means area of concrete we calculated as 124403, sigma S we consider as 90, and AS we consider as 1257 we calculated here. So final answer we get 735 150 Newton, means divided by 1000 you get 735.15 kilonewton. So in this sum the trick is arranging the terms and interchanging the terms reversely and inversely. You need to understand what is given in question and what is to be found out. If you confuse with the notations and units, your answer will get wrong and you will not be rewarded marks in the answer paper of university. So step by step you have to go with precautions. Each time you have to calculate each value very carefully, so that if even a single value from start you get it wrong, ultimately your answer will be wrong and it will be marked as 0. So go through these sums properly, write these sums on your own notebook or on a blank paper, and see which doubts you get, so that you can contact me through message or call. Thank you.